Yeah, today we're talking about Agentic AI. Before we sort of get into today and why today is such a cool event, I just want to give a quick shout out to our sponsors. We have Huddle and the Motive team, and they're the ones who are recording all of our videos. We have Boast as well, Neo Financial, Skip the Dishes, Crestview, as well as Alberta Innovates too, and our boy Gerardo and the whole team at the Pioneer. Maybe a round of applause for the Pioneer who has this every week. Cool. The way today's going to work, I'm going to call up our excellent speakers, and we're going to have a conversation about Agentic AI, but also practical use cases, how to use it, when to use it, and then we'll have about a 45-minute conversation, and then with 15 minutes, we're going to flip it over to you guys for any questions that you guys might have. So if you guys do have questions, save them till the end, and we'll do our best to cover as many as we can. Maybe a quick ask as well for you guys. We're gonna send you guys the full length video as well, a link to it on YouTube. And so if you guys want to subscribe, that'd be awesome. But we'll email it to you guys after too. So if you guys want to watch it, maybe 2 or 3 times, however many times you guys want to watch it. Cool. I think that's enough precursor. Let's jump into the panel. Let me call up Patrick and Wish, who are going to be joining me on stage. Give it up for Patrick. Please, guys. All right, Agentic AI, big topic. Well, I think we're gonna have a lot of fun, but maybe give us a little intro on yourselves. And Patrick, you just joined Arcus as well. Maybe talk to us a little bit about what Arcus is doing.
Sure. So I'm Patrick. Pleasure to meet all of you guys. I am new to the Calgary scene and first time here at Tech Thursday, so thank you for hosting this. So Arcus Power, for those of you guys who don't know who it is, so we are a company that has the largest database of...
That mic's louder.
Okay. So the largest database of data on like the energy sector in North American markets. And so with that wealth of data, we can offer products to our customers, and those would be generators, transmitters like ISOs, and large energy consumers. And those products that we offer can be things like forecasting products. They can also be products that especially like large energy consumers can use to strategize when they consume energies and kind of help manage their pricing. So that's who we are in a nutshell.
Before we pass over to Wish, what about you and your background? Because you are actually based in San Francisco and just here for Tech Thursday.
Sure, that's right. I came all the way here just for Tech Thursday. No, so I spent the last 20 plus years in the Bay Area working in .com space, all the buzzwords you guys can think of. And so obviously that included AI in the last 10 plus years. So for the last 9.5 years, I was at a company called Clary. So we did forecasting solutions for the enterprise sales type of market. So similar type of use cases, but just different type of data. And so I got recruited, fell in love with the company, fell in love with the market opportunity. The energy sector is going through transformational changes, right? So the demand of things like AI, Bitcoin mining, the demand is going through the roof much faster than their ability to increase the generation capabilities or the transmission capabilities. So I think it's a great opportunity for a company like Arcus. And also, battery technology is improving. And so one of the things that's unique about the energy sector is until fairly recently, you could not store energy the way you can store oil or gold or things like that. And so the dynamics of the market are going to fundamentally change. And so I saw a really unique opportunity to join an emerging and market that's going to experience transition, and I want to be a part of that. So The team and the opportunity were just too much to pass on.
Yeah, that's awesome. Wish, give us your background.
How many of you guys have seen me talk before? So I just, God damn it. All right. It's not
that much though. You got a lot of people doing that still.
Oh, okay. Big words. I use big words. I'm an AI systems engineer. How many of you guys know what an AI systems engineer is?
Okay. That's so few.
That's perfect. How many know what data scientists are? Okay. They build the Lamborghinis and Ferraris. I get to test drive them. So I'm the guy who actually builds the factory and scales it up in the enterprise. So I work down about 50% of my time. I work for my biggest client is down in Texas, in Austin. It's a hedge fund, commodities trading. How many know what commodities trading is? Okay, good. Power, gas, crude, etc. So they got all these super smart Cornell, Berkeley folks. The other half I spent up in Calgary. Arcus Power is client. This is doing some cool shit. We're all doing some cool shit. We'll talk about it in a bit. And then I'm working on 2 AI data centers in Virginia. Drop my fucking phone. By this way, I swear quite a bit. Hopefully that's okay with you guys. That's my bag. Oh yeah, I also teach at University of Calgary an AI program. I also teach at Queens, and I have 4 degrees, which I'm not going to get into because I'm going to bore you guys out. So.
And Wish does write a great LinkedIn blog on energy.
Oh,
and
there's the
AI.
plug. There's the plug.
So if you guys don't follow it, you should. Cool. Maybe also I'm gonna follow along Wish's hand raising. But who here is like actively? Who here is like a software engineer and is like dealing with some of these tools? Okay, cool. Who would like vaguely call themselves technical? Okay, cool. And for the most part, not technical business people who, like everyone else, would maybe fall into that bucket. Yeah. Okay. Cool. Yeah. Okay. Cool. So we'll do. We can dive deep for the technical folks here, but we'll try and keep a high enough level so that everyone can walk away with something. So what I wanted to do, I wanted to talk generally, get everyone on the same page. When we talk about agentic AI, what do we mean versus other kinds of AI? And also talk about when and when not to use it. Then I want to talk about technical frameworks, like how should you actually build it? And then we'll talk about use cases and how those use cases change from when you're first launching it to later on. So just so you guys can sort of walk along the agenda with us. But yeah, maybe Wish, what is agentic AI? What versus maybe generative or other forms of AI?
Besides like the most popular overused buzzword right now. Okay, so how many of you guys know what the difference between, I do a lot of Q&A just to kind of gauge the audience. How many of you guys know what like the difference between an agent and an agentic AI? Okay, so for those that don't know, agent is linear, one task at a time, and I'll do that. Agentic AI is a handshake. When 2 agents talk, or 3 or 4 agents are talking to each other, that's agentic AI. Under those 2 categories, there are 3 other subcategories: search, retrieval, and action. Search is when they go out and do deep research for you and give you returns, or they go inside. Retrieval is when they start talking to your database systems, and action is when it takes an action on that. So that's kind of like the high-level technical acumen.
Okay, Patrick, maybe if I'm at a company, when would I want to sort of leverage an agent, or when would I want to start considering using agentic AI?
Yeah, so probably the easiest way for me to answer that question is,
If you can hold the mic a little.
sorry, the easiest way for me to answer that question is think about where your people, your teams spend time, and think about an agentic AI, you can think of it as a person doing that task, right? One of the things that agent AIs have is they have the ability to kind of reason through the request, plan like a task of how to solve the request, and then act on it, right? And it's the same kind of flow as if you have a new hire or an intern. You have the same kind of steps you have to go through. You have to kind of walk them through what the task is going to do, and then equip them with the knowledge and the tools they need to do that. And I think when you have that kind of dialogue, or if you can frame your problems in that way, that gives you a good clue as to when you can apply agentic AI.
And when can you have confidence in an agentic AI? Like when can you sort of walk away, or can you never walk away?
Well, you would say, when can you walk away from a task that a person is doing? Right. So the short answer is never, right? We all have controls and systems that help us make sure that we are always either maintaining quality levels, keeping within cost profiles, or improving continuously, right? So the whole kind of continual process improvement type of culture, right? It's no different with agentic AI, right?
Yeah, and Wish, curious on your thoughts on like how do you build an agentic AI to avoid hallucinations?
Oh, we're going to the hard part. Okay. So
because presumably that's what you're talking about when you're talking about like not having confidence, right? It's going to hallucinate. It's going to be right, or maybe like how do you avoid some of those flaws?
How many of you guys have read "Attention is All You Need"? The transformer architecture. Okay, that's okay. So high-level primer is basically next token prediction. So the way it works is when you give it a bunch of text, that next token prediction gets loaded up onto a bunch of GPUs. It makes the next token prediction, and then it takes that whole context, puts it up into a GPU, and loads it up. And every single token, every word that you're seeing is actually a probability. It actually is giving a whole bunch of other words and is picking the most relevant word in that context every time, every word. So if you have 1,000 words and the 1,001 word comes, it loads it up, goes all the way back to the GPUs. And the reason I'm telling you this is because LLMs have an accuracy problem, okay? They're non-deterministic. We call them parrots, stochastic parrots. They repeat themselves. The problem with this is like LLMs on average are 80% accurate. Do you guys know how I was talking about the handshake? Now, what happens if you have two compound systems that are 80% and 80% accurate and they make a handshake and they give you an output? Your accuracy drops down to 65%, 64%. This is the part that you have to start thinking about. So going back to your original question about Judge, there's a framework called Judge and evals. So Judge is basically a main model will sit on top, and then you have evals. What happens right now is most people, when they're doing the Judge and evals, they actually have one master model, like an LLM, like an Opus 4.1, which is the Claude, the hyper-reasoning one, and then they'll have a bunch of like small models, like let's just say like GPT-4o, which is deprecated now, and then they'll have the Chinese models. They'll all kind of go and give you the return, and they'll have one judge model to kind of give that answer back. The part that you have to think about when you're solving this problem is to say, hey, listen, I have 5 that are giving me the average answer of this one use case for this number. I have a high probability index score that is probably right. And that's how you configure the judge model to say, listen, 5 models return something very similar, therefore it must be slightly accurate. And we'll talk about the use cases in a bit, it'll make it more tangible.
You're curious, like coming in knowing that any sort of LLM is only going to be 80% accurate, dropping down to 64% accurate. How do you come into your engineering team at Arcus and give your engineering team the confidence to stand behind the product and tool and in some of these meetings? And I guess not just the engineering team, but the team in general.
Yeah, so we're really getting to what Arcus is doing in this space and where we are, and also the direction we want to go, right? So I should probably give a little bit of background around that. Like probably many of you, the way that we got started in that technology space is, ChatGPT came out, we thought that was neat, we try it. And obviously we're looking at certain workflows that take us a lot of time to accomplish, right? And then as we see potential, we started creating products, and we can talk more into exactly what we build and how we did it, right? But now the point that we're getting at is that what is the next frontier in terms of what we're concerned about? And it's not technical, right? We can have more automation and let the tool go farther. The part that we're touching on, where I'm bringing this up, is that right now the frontier that we're facing is one of confidence, right? We know that there's potential for hallucinations, and we want to deliver a product with predictable quality and cost to our customers. And so we have to achieve those goals. And so now the frame that we're in is, how do we build the processes around the technology so that we can kind of have that predictability around the quality that we deliver, right? And again, this is where the paradigm that we're falling back on, or we're gonna start to roll out, has a lot more to do with how we manage people than something that's intrinsically different because it's AI, right? At the end of the day, customers don't know how the product came about, right? They didn't see how the sausage was made. They just wanted a nice, quality product, right? And that's kind of where we're being. So I have a personal background from years before where I worked in the crowdsourcing space, in the freelance kind of sector. And one of the areas that I'm tapping into to kind of bring this insight in is, when you have a gig economy type of work situation, it's really expensive to hire someone, right? You don't want to go through an interview process, fly someone in from the Bay Area to go fill up a job. So you need other mechanisms to onboard new people and keep the product you deliver to customers, where you know nothing about those people, in a predictable stance. Like, can I deliver high-level quality product at predictable costs while I'm adding new writers, new reviewers, new photo editors? And so that kind of, in AI they use different terminologies, right? But it's the same kind of flow. You have you have a creator, and then you have a reviewer. And you see this pattern in AI all the time, where you have one challenge the other, right? And that's the fundamental thing. And again, a lot of that inspiration is from managing people, but that's what it is. So now we're at the next frontier for us. It is, we want to build that business confidence. Once we achieve that goal, then we'll do more automation and more, stuff. But we'll never be completely ever, set on its own in a fully automated way. We will always have spot checking on some, it's a matter of degree. Which degree will deliver the highest quality we want to have at the minimal cost. So we'll figure that out, right? Yep. But that's the general direction.
I'm curious, future state, when you talk about managing people, when I used to work at tech startups, we would also talk about like managing expectations for your customers. Is there ever a point where we also say like, oh, maybe we'll just manage the expectation of the end customer, where they only expect it to be right 80% and then have the opportunity to go and use your tool to like review and see if it ran correctly, if they think something's off, or like is there ever like a training the end customer, or you guys always want to stand at that like 100% quality?
Yeah, I think that one's not an easy one to answer in a one-size-fits-all answer. The reality is that there's different types of products and there's different impact on the quality problem, right? And so it depends on the stakes. Certain products, like a Netflix situation, can be 80%, and the customer can report a problem. But if you have a $300 million deal that's going to be at risk because of an error, that's harder to. So I think it's on a case-by-case basis, right?
Yeah.
In that situation. Yeah. I don't know, do you want to add to that?
Which let's get technical. Talk to me about like best. You talked about judge eval, but talk to me about some other like best techniques to actually building some of these frameworks. And when you look at building a framework for the agentic AI, maybe like walk us through what that looks like when you're even building it.
Sure. Let me ask the audience: do you guys want use cases or frameworks? You want the IP. You want to. How many consultants in here are going to take my freaking idea and sell it right now? That one right there is laughing the loudest over there. So, all right. Okay, so here's the problem statement that we solved. So how many of you guys are from oil and gas? Okay. If I say jet fuel or naphtha, does that make sense to you guys? Okay. So
I mean, can you break those down for people who don't understand?
Okay, so
there's like two heads.
upstream heavy crude gets refined down in pad 2, which is Illinois, etc. So we ship a whole bunch of inventory from up here all the way down to pad 2, which is where the Trump state is. Illinois, should I? It is a Trump state. All the way down to Chicago. And what they do is, that's about 65 million people in the world. And we need to sort of like give them fuel. The refineries are all over there. And the refineries take that and they make low margin product, which is heavy crude that we make, and they sell it up at higher margins. That's the problem statement. Got cool? Okay. So what we did was, the problem was, these are organizations, for them a $10 million or $20 million accounting error is a drop in the bucket, because that's how much money a lot of these organizations upstream make. So the problem is, like, these invoices, supply contracts, they all flow in. And this is actually a failure story, but then I'll tell you guys how it worked or how we fixed it, because everybody likes to know about the pain point. Every time these supply contracts that are written in the inventory, et cetera, line by line, there's an accounting number, right? Those numbers come in a goddamn PDF format. And sometimes the people will take that number and scribble it off top and write, and scribble with hand. So the problem statement was, we cannot reconcile from our ERP and accounting systems how much inventory is leaving and how much is going, because if a $20 million accounting error happens and somebody doesn't pay an invoice, nobody actually physically tracks it today. Believe me, this is an actual thing today. And so the idea was, how do you do it? Like, can you use Agentic AI to do this? So what we did was, we took all the invoices and the PDFs together, and we parsed it, and we threw it into an LLM to do OCR, and it combined it by OCR, optical character recognition. So we merged, basically saying, read an image, get the data out, but also feed it into an LLM, which is a multimodal omni model, which is that it can do vision and it can also do text. Takes the data out, parses it, looks at the OCR output, looks at the LLM output, says, oh, the number is kind of in the ballpark, and then takes that number and puts it into a CSV file with the contract ID and the number. 80% of the time, the freaking thing worked. 20% of the time, didn't work. And here's the problem. If you have an $8,000 invoice, and in that CSV file that somebody's going to look, and by the way, there's thousands of these invoices that go around, right? Because there's jet fuel, naphtha, there's marketing group, there's a whole ecosystem that's created around this. If you go from $8,000 and the LLM and the OCR put that as an $8 million number, it's a freaking headache, because the receiver is going to say, you never sold me the goddamn inventory. So our problem statement was that accounting error that we had to fix, because actually this model, we got it up to 95%, but the 5% was still too high that we cannot use the Agentic AI system for that, because it's like the misdiagnosis of cancer patients, right? Like, the bar is just that high. So when we did the QA, they actually didn't mind going back to the old way of having 5 or 6 FDEs that actually parse through this data, because they didn't want to be in that accounting error, because that's one $8 million error. You do 10 of those, that's an $80 million accounting error.
So there's actually just no solve in that situation.
There is a solution, but I'm not going to give it to you guys, because the consultants are sitting right there.
But I will say, there's actually a lot of insight in what you shared, right? And I think if you guys, so how many of you guys are looking at starting AI projects or LM projects in the near-term future? Wow. A lot of hands, that's great, right? So think about systematically breaking down the use cases, right? So we talk about when you can have a potential for value, right? So, and you can look at the workflows and see what people are doing on, right? But what Wish was mentioning, right? Like, what is the, the rate of false positive, false negative, true positive, true negatives? Have a good understanding what that means for the business, right? Because if like a rate, if false negatives or either of the falses are not tolerable to their business, that's probably not a good use case for AI, right? Or if it is going to be something where the savings in time are so compelling, right? Then mechanize a process that manages the risk. So recognize the risk and then manage a process around it, right? So it's part of the system. And again, this is why I keep looking at it from a people perspective and then think of it as capital investment to kind of accelerate and improve the economics of the business.
Is there a use case that can back that up where you did that, where you said, okay, here's the time savings are so good, we are okay to take this risk, and here's how we're gonna like strategically add people to make us a little bit more confident? Like, can you walk us through like an app tech?
I mean, I'll go back to the example that I give. So at Arcus, one of the things that we do is we generate daily reports about the market conditions, right? And for the longest time, our analysts, so these are PhDs in electrical engineering that specialize in energy systems, right? So we have these analysts on staff, and they have to write this report every single day. And that means you look at the market conditions, the weather, the generation, all that kind of stuff. And it would take them over 2 hours every single day to do this. That process with LMs has gone down to 15 minutes, right? And we can automate it even more, right? Because right now, we're on the trust barrier. So that the 15 minutes is the time that they spend to trust and to perhaps edit what is being generated in that. So that for us, the time savings is huge. We have a very, very small team. So 2 hours every day is a lot of my FTE headcount, right? And so we need to kind of harvest that, right? And so this is an example of how we manage the risk right now. So right now, we still have people that are on call that do these kind of reports. And now we're kind of equipping them with more and more automation around what they do as we understand what it is that they're checking. And then we're going to, take the next step, automate that portion, and then, keep moving down the ball so we have more automation around that.
Here's a use case that worked with the IP. You're welcome. So essentially what happens is at Arcus, we have a dispatch desk. So dispatch desk, how many of you guys understand like the power market, by the way? It's just a little bit. So power market is, okay, there's some power folks.
These are so niche.
Fuck. All right. Simplify. So dispatch desk, they get a call, say, hey, listen, you have this amount of power. We need it right now. ASO is a regulator. They tell them, hey, we need this power, and you have about 10 minutes. So if your asset is a combined cycle power plant, it will ramp up in 10 minutes. That's how long it takes. It's like a car engine, right? It needs time to ramp up and warm up. So the problem is that when ISO kind of comes in, they say, we changed the rules today. And nobody freaking knows. And then you get like a 100-page document, and you have to go parse through it and figure out which rule applies, because for that 5 to 10 minute interval, when you dispatch the asset, there's tens of millions of dollars, by the way, if it happens every day, on and off, on and off. And so the idea over here is, well, somebody had to sit down and go through that reg document to be like, were we compliant or not? And compliant really means it's like, hey, listen, I've decided to give power to you tomorrow at 5 p.m., and I did not. I'm in violation. So that penalty is going to be X amount of dollars because you weren't able to provide that power. And it ends up being like very, very tangible numbers if you compound it enough times. So what we did was we're doing this right now in the dispatch desk at Arcus, is we have a bot that goes and logs into AUC's website, pulls the latest reg documents, because they publish a shit ton, by the way, parses through that data and says, this regulation is going to have this impact on you if you do not follow that. So usually what will happen, it would take us 2 weeks or 3 weeks to parse through that, and then you would get an invoice, and you would be like, well, can we reconcile this number or not? And believe me, these numbers are in the millions. So now, within 15 minutes, when that reg document comes in, is a Power BI report, the agent goes, parses through it, connects to the bot, pulls all the data out, and there's about 5 models that run in parallel, and all 5 of those models. And this is one thing I wanted to kind of tell you guys, go with a multimodal approach. Multimodal approach is the best way to build a solution in LLMs. And the reason is because people go and actually Patrick taught me this. Like essentially what happens is that people get signed, like, in energy companies, you are in these long-term MSAs, right? Management service agreements, and you go up to a procurement, you like do a 5-year lock-in with some vendor. Like by vendor, I mean like a software stack. That doesn't apply in AI anymore. You have to go with one of your contracts and get 5 of them, all of them, and then feed it into the model. Because guess what? Every quarter, a newer model comes out, and you want to test it out. Because guess what happens when you build a solution, a new model comes out? Your QA fails every time because the model weights have changed. And unlike software where you have the features coming out, this new system that you have built, the model weights have changed. That means all your regression tests, all your QA, quality assurance that you ran for that report, no longer applies to the new model because the model is completely non-deterministic. Means you got to do your QA all over again. And if you have 4 other models that haven't been updated, guess what? You have some time.
I was going to add
Yeah, go for it.
So still on the topic of use cases, right? One of the things to understand about LLMs is they're not great in real-time scenarios, right? And so where latency is an issue, right? You got to really think about how to best leverage them, right? So we have situations at Arcus where we have some high latency situation, some fast latency situation that we have to do. We use LLMs in an ancillary loop. So we have, for example, feeds that we get. Those feeds may break. So we don't have the LLMs interpreting the feed. That would cause too much latency. What we have is the LLMs troubleshoot when they break. So just think about that flow where there's lots of places where they can add value that solve business problems. It doesn't have to be that everything goes to LLMs, right? We're still, simple automation and, works great.
For some of these folks who are hoping to just start companies, is there like, at what point do you start thinking about the cost? And at what point does it become expensive? And do you think about GPU automation?
Yeah, so you want to think about cost day one. It's that simple, right? It's really easy for the cost to run away on you when it comes to these LLM models. These are like high value add products, and the .coms companies behind that, they know how to value-based pricing. They mask it as pay-as-you-go models, but these are very much value-driven type of pricing situation. So it can get expensive real quick. So you got to learn about, there's systematic ways. How many guys have heard of a book called Crossing the Chasm? Oh, good. How many guys have read it and actually just buy into all the principles there? Less, that's okay. So, no, they're real too. To me, that kind of mindset really kind of helps in this scenario, right? It's going to be a very expensive product. So start small, get a proof point, get the market to validate the value that you're delivering through that. When you achieve that, then make the next investments, right? So our journey at Arcus is exactly that. We started very small, right? The market has proven our solution. We're taking another step. The market is embracing that solution. Now we're about to ready to take additional steps, right? But that is one of the ways that we've managed our costs. So for example, you don't need to start with the LangChain or any of those big solutions. Those are going to make your costs go way high right at the beginning. Start with APIs that you call, manage, get to understand what the context is for your product, like your prompts and the other stuff you need for the context engineering, right? Get that all validated before you start with the big investments, right? And so you manage your costs. Now, as you pointed out, models evolve. You want to get new models to power your solutions. They'll be able to do more, have better reasoning capabilities, have more capabilities of using tools around automation. But you have to validate that your logic, your context engineering, your LLM stuff is working properly, right? So build strategies. So the way that we're doing it at Arcus, one way to do it is we do our course testing on free models because we can manage our costs. So all of these open source models, you can run them on local hardware or run them on cheap cloud solutions. When we get the course validation that we're looking for, then run the same set of tests and do the fine tuning on the more expensive models, right? And that way you can kind of balance your costs.
Let's play a game.
More hands up?
No, I'm not going to do that. I've given that up. So you know what the hardest part about LLM deployment and agentic AI problem is? It's not the build. It's not the POC. It's sustainment. It's freaking a nightmare, right? So the first question, and usually we go, and actually me and Patrick had this exercise too because we were evaluating some AI tools, is budget forecasting. And the reason why budget forecasting is really high, like hard in AI agents, is because how do you predict user behavior? You can't, because you don't know how the people are going to use that tool that you're about to give to them. So if you go and sign a $100,000 deal with Claude, and here's another example, right? So another use case, we were deploying it to operators. So they manage this midstream asset like a pipeline, and they have compressor stations. And so the idea was like we built an agentic AI system after. So there's a model that runs, there's 257 machine learning models running, operational, they're getting tangible result, and then we plugged an agentic AI system to solve it for them. The first question I got asked is like, how much money do you need for Q3? And I said, I don't know. Because these are, I'm going to actually give you the hook in a bit, what happened. But I was just like, I don't know how they're going to use this tool because they might like it, they might not like it. Do you know what happens when you deploy an AI solution to a bunch of engineers?
No, what happens?
Yeah. I'm going to make it even more complicated. Do you know what happens when you deploy an AI engine for a bunch of reliability and process engineers with an electrical engineering background? They got a Ferrari. What do you think they're going to do now? They're going to try to freaking break the thing. They blew my budget in a month that I had for the entire quarter because the usage was so goddamn high. And guess what happened? We deployed it during shoulder months, which is that when there's not a lot of inventory flowing because it's not hot, it's not cold, it's in steady state, the asset is. Guess what happens during shoulder months? They don't have much to do. So now they have a Ferrari, it's shoulder months, and they're sitting there, and they're just going to town. So forecasting budget is something that you have to worry about. The way we manage is we put a sandbox, and we basically go and figure out who the power users are in Active Directory, if you guys are in Azure or GCAP, and you curtail them. And you say, this is how much budget you have on a per user basis because I know you're a power user. And then once you do that, you start doing your budget forecasting because on all these hyperscalers, I don't know how many of you guys are doing, but I know some of them are over there. It's like, the Azure and GCP, they give you a forecast curve like this in the tool for cost management. Yeah, that's bullshit because you have no freaking idea how these people are. So suddenly what will happen is like one weekend will come, like a long weekend, and your forecast curve for budget will just spike like this because there's a power user that's hammering your system, right? So you have to basically curtail them that way.
What about GPU optimization?
Oh, yes. You want to nerd out?
Yeah,
so,
nerd out.
So I gotta give a shout out. There's Javi over there. He's at Arcus Power. Dude is a freaking genius, by the way. He has a. We're doing some cool shit at Arcus. So we have a whole bunch of A100s, 4500s. We're playing with some GPUs. So what we're about to do, and Patrick greenlighted this. I don't know why. You give two engineers, Ferraris now. So good luck with that.
You'll find out later.
So what we're doing is we're deploying a whole bunch of the free open source model. So we have GPT-4 OSS that's going to get deployed. We're going to have Qwen, which is the Chinese model. And we're also going to take GLM 4.6. Like these are all the open source models, right? What is cool is once you do this on your own hardware, your cost just goes to nothing, like net zero. All you're paying for is the capital sunk cost for the GPU. And these are not like the NVIDIA H100s or the H300s or the GP300s, right? Like these are deprecated, almost like 3 generations older, and you don't need much. We're going to put it up on there, we're going to mount it, and we're going to do all the prototyping on it to keep our costs down. It's very cutting edge, right? But highly recommended because once you do this, you prototype it on these very, very small. So you know how like a lot of these models, there's something called parameters, right? So these models have a shit ton of parameters. So 430 billion parameters is like the Qwen model, which is like a really, really big model. You don't need that in today's world. You just need a 30 billion it sounds like a lot, but it's not. And you fit it into 1 or 2 GPUs today. And we're going to roll it out to the internal power users because like Patrick said, we have a whole bunch of PhDs and AI engineers at Arcus, and we're going to enable them and say, go to town, see what you can do. And cost will not be an issue for us besides maybe the power bill, but it's like at the 300 kilowatt GPU, not a big problem.
So the process here is plan ahead for the cost, anticipate it. Also, like you alluded to, we're buying tools. Like we want to make sure that there's mechanisms in place for us to limit the cost, right? And so there's fallback schemes, right? And so these systems that we're doing, like we do plan on equipping our engineers with models that might be like Claude-based models and stuff like that, right? But we don't want the work to stop if we run out of credits or if we hit our spend limits, right? And so part of our strategy that you're alluding to is we're implementing fallback schemes, right? So these servers, they can run our course unit tests, right? When we are trying to find out, they can also run the models when we fall back from the Claudes or the other kind of higher price models, right? And so it's nice to have that relief valve. It doesn't necessarily have to be on your own on-prem physical hardware. You can do the same on various cloud solutions that are, so as long as you're dealing with cheap GPU cycles and you're using open source models, you'll achieve the same kind of goals. But the recommendation here is plan that valve, that release valve, so you have that fallback position in play for this kind of use cases.
Maybe last question from my side before we open it up to the audience. Do you guys have like one more use case each, but maybe like something silly, like a silly?
This is going to be super simple. You guys know this. I know you guys know CRM.
Yeah.
Yes. How many know CRM? Yes. All right, so look at that. I got a higher hit rate. I got a higher hit rate. Okay, so this is what we're doing. We actually talked about this today, and it's been so you know how you in Teams you guys record the meetings, right? So the problem with the Teams one is that getting the transcripts is like a bitch, right? So there are a whole bunch of tools out there like Read.ai, Firefly, etc. Like there's a whole bunch of them. What we're going to do is we're going to take that transcript out and we're going to build a single source of truth for every conversation that's ever had. With the clients, with internal, external, with permission, obviously. Once you do that, what we're going to do is we're going to plug the LLM models to that pantry, I'm going to call it, where all the resources are. And we're going to say, okay, what part of this data belongs inside the CRM? We do not want to use the CRM AI. And the reason is because once the data gets plugged into there, we can't get it out because it's a bitch to get that out. So what we're going to do is we're going to plug it in there, and then we're going to push it into the CRM for all the context-relevant conversations that were had. And there'll be a record off of it. The second thing the reason why we're doing this is because guess what comes out of that little pantry? Product ideas. Right? And because all the conversations will be there and you will have this database. So we'll just go there and say, listen, last month, what are the 5 top common use cases or pain points for people that are kind of talking about this? And like, just to give you guys an idea, like the sales pitch at Arcus is very organic. We don't need a sales pitch because they just come to us and it's such a power, right? It's the hottest topic right now, and energy is the hottest topic. Batteries, hottest topic. AI data centers, hottest topic. So essentially the idea is like they'll come and they just give us a category of it. Then we know exactly what the highest hit rate is because we know that 10 customers asked for the same goddamn problem. And so now we have a product roadmap.
You asked for a silly
use case.
Wow.
That was silly. That's money in the bank.
So I'm a nerd, so I don't do silly. I'm sorry. So my interests lie in trying to leverage LLMs and AI in the whole like self-healing server type of roadmap, right? I imagine people interacting with the products they create at a much higher level of abstraction. I'd love to see spec-driven type of interaction models with the AI to create our products. I also wanted to go complete round trip. I would love to have all of our production telemetry tied into that and have that fed back in and have the system kind of heal. So I know we're probably a good decade or more away from that, but I think there's lots of steps that we could take along the way to get there. So that's kind of where I spend my energies, daydreaming about things like that.
Yeah, that's awesome. Well, what about philosophically before you open it up? What's the future of work like for humans?
Wow, thanks for prepping us on that one.
You're welcome. Yeah, I just had the dots. Yeah, that'd be fun.
So it is, I don't have any answers, right?
Okay.
It's this one of those things, but in the extreme, it really suggests that as a society, we have to think about how our economy will function. Because you cannot have a commercial or consumer-based economy if people don't have jobs that can't buy stuff, right? So in the extreme, there's a lot of questions to ask there. So I think, it's an exciting time for a technologist like me to be in the energy sector.
Yeah.
I think it must be an exciting time to be an economist because it's going to be the defining, I think, problem of the up and coming generation, right? So.
Yeah.
AI in the middle, humans in the end. There's no way around it, right? I work on hard assets with operators. Like imagine an AI agent telling a power plant operator to shut down the plant with no explanation. I'm very bullish in the idea of augmentation. So everything that I've seen intangible in the physical assets world. For the first time, I think one of the key takeaways I would say is, for the first time in human civilization, we've figured out how to translate molecules into intelligence. It's never been done before, right? And for $20 subscription. And so I think, if you guys go home, as the one takeaway is don't just learn ChatGPT, learn Gemini, learn ChatGPT, learn Claude, learn all of them. And you will learn that there's a certain way that they talk to you and they return responses. And you will quickly pick up the ideas of how you're supposed to interact. Because I can promise you the training data that they have in the back end is not all the same. And so the idea would be like, when you have use cases or problems, you'll be like, oh, that model over there is actually better at doing this. And like I would say, like as a takeaway, just learn them all. And half of them are free. Just don't put your blood work or your lab work or your financial data in there. Just don't do that.
And keep the scope narrow, right? So we talked about one system, the system I described for the use case that we're using at Arcus. We have 8 agents that support that one function. So keep it narrow. You get a lot more success by keeping things very narrow.
Cool. That was awesome. Thank you guys so much. Give it up for these guys. Perfectly on time. Guys, let's open it up to questions. Any questions? Yeah, we'll start here.
My question is for Wish.
Hi, Sandra.
You have access to elite brain power with people who you work with. Plus, you have an extraordinary academic background, extraordinary experience. You push the envelope. You're very creative. If you had
These are just compliments.
this, this is a setup.
Sounds like it. I wish you fix it.
This is Star Trek thinking. If you had unlimited financial resources, you have access to the most elite brain power available. What would you create and why?
Arcus, right?
Holy shit. I've thought about this actually, believe it or not. The way to accelerate human intelligence, okay, let's just table this. There's a lot of negative limelight around AI. Everybody's scared of AI, right? Everybody's scared of AI data centers. They're going to take all these jobs away. It's not true. I can promise you that. 100 years ago, if you went back and you talked to somebody, they didn't know what a TikTok influencer or a software engineer was. We don't know what's about to come. But to answer your question directly, what I would create is an intelligence hub. I've thought about this. And the intelligence hub would be democratized to everybody for free. And the idea would be that anybody with the smartest person in Uganda or in South Africa or in Bangladesh or in Canada would have the ability to just basically ping that and not have any limitations to actually be like unthrottled. Because there are so many more smarter people than anybody in this room, even in Stanford or whatever, who are not given that opportunity. And I think that's kind of where we want to go, is have that hyper intelligence where they actually can access it and build it and cure the largest things. And you know, I truly do believe that the next generation that's coming in will cure cancer. It will be cured. It will be cured. Diseases will be cured faster than anything. We'll have simulations of the next flu that is coming out. And that intelligence has to be democratized where people can just be like, you know what, I can just make it. Life is going to be okay. It's not bad. And I wish I could build that today. But if I had that, I would build that and I would give people certainty that the world is not coming to an end.
So you're the CEO and yeah.
Very interesting talk. Thank you for your insights. Next, I have a question regarding the hallucinations. So today we talked a lot about hallucinations, which are happening when we are working with the LLM models. And recently, LLM models became even more powerful. So become better, and better. And now I think one of the latest news is they beating humans in math exams on the world stage. But at the same time, they still hallucinate. So they still give us false answers to the questions, whereas the humans say much better this, so they can execute reasoning, right? So they critical thinking, and they can say, okay, this is a lie or this is the truth, which when they interact with people. So I'm wondering if there is anything fundamentally wrong with how we create these models, so they still have this efficiency and basically are fighting with the symptoms and not the disease.
So essentially, these models are not stochastic parrots. They repeat back. Two ways. One, you can solve that problem today, generally speaking. There's two words. If you guys really want to know, Google it. It's called context rot and context poisoning. Okay, just look these two things up. I'm not going to get into the technical stuff of it. And there's a way to manage these two things. It causes a lot of headache, but if you know what you're doing, you can fix that. Now, how many of you guys have heard about reinforcement learning that was invented? Okay, so a few of the founding father of reinforcement learning is Richard Sutton. He comes from UFA, right? There's a podcast that I would highly recommend to you guys to read about the problem of hallucination, but just once, like a very brief description is reinforcement learning is the way, just think about it like kids, right? Like you have an objective function and then you behave badly and you push them and there's a state and they have to learn about the world. Well, I mean, that's how I was raised. My dad was like, go figure your shit out. So, and didn't do bad. Okay. So essentially the idea over here is that reinforcement learning, and if you guys think compute is going to be bad right now, wait till RL goes at scale, right? Like you guys should look it up. That compute is going to be like vertical. The problem with today's technologies is that they're built on neural nets and they are black boxes and they're not. Reinforcement learning will solve that problem and it is coming. And the problem is that we don't have enough compute today. But tomorrow's architecture that 2 or 3 years is going to come at RL at scale, because today's one does use RL, but not at full scale to RL. There's a podcast called Dwarkesh's podcast with Richard Sutton. He literally directly answers this, and it's a very heated exchange podcast. It gets a little bit technical, but just feed the transcript into ChatGPT and you'll get the gist of it.
Hey, quick question. How is this domain-specific models are evolving? It's more relevant to this city, energy and oil and gas. So how are they evolving in your views?
So I'll answer in the general form. So these models, like general purpose LLMs, the same kind of embedding technology can be used to train models in specific domains, right? So there's a time and place for each of these, right? There are different tools for different jobs. Certainly you can get a lot of mileage in terms of improving, say, forecasting accuracies and stuff like that with these kinds of domain-specific LMs. And I think there's a lot that has been published. I think LinkedIn did some of that stuff. I think Stripe did some on credit card transactions, fraud detection, stuff like that, right? So there's a lot of bang for buck you get by doing that. But it's a really expensive proposition. You need the budget of a LinkedIn or someone like that to be able to pull that off. We certainly are toying about it because if you think about what our space is, it's not unlike credit card transactions. We've got offers that are being put up to generate energies. We've got consumption that needs to come in. We have to match make and combine the two. There's demand response situations. So I think we're imagining a future where we will dabble into that, but we're not ready for that just yet. Did I address your question? Okay.
Yeah, I have a question to follow up the one of ways you would implement AI if you could. What are ways you wouldn't, that you would advise against, that you feel cautious about?
100% automation, fire and forget. I would definitely avoid those use cases.
I got a list of those, but essentially anything that is going to have a direct, like power plant is a good example, right? Anything that is tangible that will put lives at risk using an LLM, right? Not AI, LLM. Because again, you don't know how it came to that conclusion or not. So any of those things that come down, this is why I kind of go with the framework, right? AI in the middle, LLMs in the middle, humans in the end. It's the framework. And it has to be there for a very, very long time. It's not all doom and gloom. I really hope you guys take that from here. It's not bad. It's pretty good.
P questions way at the back of the room here. Yeah.
There's many innovations around vector embeddings. You see the stilled models now coming out. When are we going to see backwards compatibility within vector embeddings?
RAG is dead, okay? Vector embeddings is a way of just a high-level primer. You take a bunch of words, you turn them into numbers. That's vector embedding, grossly simplifying it. Essentially, it's a fancy way of saying I can't believe I'm about to say this. It's a fancy VLOOKUP, okay, on Excel. And all it is doing is basically LLMs, when you talk, those words, those tokens, they turn into vectors, right? Matrix multiplication and tensors. And then vector embeddings is basically like when you dump a PDF format or a Word document, that turns into a vector. And then it does a similarity search and looks at, oh, this is what the context of the question is for that document, and it does a lookup. It's fancy, the VLOOKUP. That part, I don't know about reverse compatibility, but I can tell you this, that RAG, which is the technology that is coming on vector databases, it'll be dead in the next couple of years, and it's for two reasons. One, there is actually a better way to do this, and I'm going to get a little bit engineering for all the consultants who want to steal my ideas. Essentially what happens is that you kind of loop, so essentially this is how you would run a framework. Going back to Philippe's original question, what you do is every agent, when it runs a job, there's something called log tracing, okay? Log tracing is basically keeping a record of what that agent has been doing the whole time. And you put it in something as simple as a .txt file. Okay, so if you have 5 agents running, make sure that they don't talk to each other. It's 5 parallel jobs, and they create 5 .txt files. And you do something called context compaction. So you compact that, so it's like a summary of the job that it did. So now you have 5 of those. And those 5 will basically get fed into these models, going back to your original question. Now, what did Claude do? Sonnet used to be 200,000 tokens. So 200,000 tokens, roughly speaking, it's not the case, 200,000 words. Now what they did was they essentially released Sonnet 4, and they increased the tokens to 1 million tokens, roughly about 1 million words. That's enough to feed an entire stream of Harry Potter books into memory. So now, going back to the original question about vector embeddings, why do you need a technology when you can just go loop through all the files in a SharePoint or OneDrive, where the PDFs are, load it up in memory, make an agent, read the TXT file, be like, not relevant to me, discard it, and go to the next one for pennies. So to answer your question, backward compatibility won't be there. So I got a little bit technical over there, but the idea over here is you don't need that fancy technology. You can do it for $5 now.
I think we have time for 2 more questions.
There's one in the back too.
Yeah, I was sort of curious because this isn't my field, my discipline. But when you talked a little bit about how you set up these agentic AIs to communicate sort of a larger model and serve the information that way, it does sort of suppose that the models aren't correlated. And you mentioned that they are trained on different data. I'm just curious if there's any research I should look at about how similar different models are.
So the open source ones do have their papers. They're called Mixture of Experts. And you can actually go to Quinn and at Glam or whatever, and you read the papers. You said you're not in the space. So perfect. Yeah, you'll get the math. So just take that PDF and just feed it to ChatGPT.
Okay, we're getting our last question right back here.
Hey y'all, so for small mid-sized businesses that might not have the data or the internal technical teams, where are their agentic AI opportunities and how can they unlock it?
I got a bunch. Right?
You got a bunch. You want to take that one?
Can I ask you a couple of questions? SMB, so what is like software or product?
This is general businesses.
Generally businesses, well, I got to give you a use case. So you want to know agentic AI solutions, you got to tell me what you do.
Okay, let's go with a fast food company.
Okay, fast food company.
Wait, can I selfishly say, what about Tech Thursday? Do Tech Thursday. Small business.
Are you literally making me do live consulting right now?
Yeah, it is. I mean, if we're going to do a random fast food joint,
Wow.
I'll take a free consulting.
Okay. We're going to put a chargeback model over here. Okay, so essentially what I would do with the agentic AI is, I mean, I don't know much about this world, but I actually had use cases for manufacturing. No, I don't want, but let's just do Tech Thursday. Okay, you guys want to watch how this discovery session happens? Do you want to see a live session about how the Q&A happens?
Oh my God, this is great.
Yeah?
So you're going to bill me like 10 grand.
No, I'm not. Do you guys want to see it, like the playbook? All right, let's do this. Tech Thursday, what does a Tech Thursday do?
We're an events company. We host events across the country.
Okay, do you have a catalog?
No, I don't think so.
Okay, do you have a data dictionary?
No.
Okay, do you have a CRM?
Yeah, we do.
Okay.
We're CRM.
CRM always has a high hit rate, by the way. And I'm not even in sales. Like, I just know that everybody freaking has a CRM or an ERP.
What's a data dictionary?
Okay, data dictionary, good question. This is, okay.
We actually go.
Data dictionary, is this helpful, by the way? Okay, cool. Data dictionary is basically a catalog of everything that you have in your anything that's a sales product or whatever, you should have a mapping. So I'll give you a good example. Is like, okay, just a little bit of a hook on the side is like, you know how companies have multiple assets, right? Like midstream, et cetera. Well, their problem is like they have all these assets and then some random engineer will go and name those sensors randomly, right? A data dictionary will centralize that and say, okay, you know what? I have a mapping. So now I know what sensor name on this asset what the standardized name is. Does that make sense? Okay. Cool. Okay, now next question. You have a CRM. Okay.
I do have a CRM.
Do you have a record of all the calls on Teams?
No.
Bro, you gotta upgrade.
No, well, I mean, on my Google Calendar.
You want to do an agentic AI? Okay, all right. Yeah, agentic AI is not for you, but let's just play along. I'm just messing with you. So, okay, who are your competitors?
Oh, don't make me call him. No, Texio and
Okay,
Trello.
let's just say XYZ. Okay, XYZ. Do you follow them? Do you follow them?
Yeah.
Yeah, of course, they're competitors, right?
Right.
Do you have their websites?
Yeah.
Perfect. Here's what you guys do. Take an agent, build a bot, scrape that every day, over and over again. Build another agent, go out, scrape all the competitors in neighboring cities. All you have to do to an LLM in today's world is called tool calling. You write a bunch of code and says, go and reason and research on the web for anybody in this exact line of questioning with the data dictionary, and you say, point it to that global way and find me all the successful TED Talks type of call. You bring that in and you build an inventory. Now you have a catalog and you have an entire discovery session of what guests are going up, what kind of talks are happening, almost in real time. You connect that to a Power BI dashboard. Run it every morning at 5 a.m. By 6 a.m., you have a catalog of every single news release that has come from your competitors and the hit rate, and you also know which customers are going to go where. There you go.
Yeah. That was better than a Jay-Z album. A Jay-Z album is $1 million worth of game for $9.99. This is free. All they have to do for that is to subscribe to his LinkedIn blog.
Yo, seriously. All right.
Cool. Awesome, guys. Thank you so much. I know there was still some more questions. I think if you guys want to ask them, the price is one beer for these folks. But you guys are welcome to stick around, hang out, and hopefully I'll see you in a couple weeks at the next Tech Thursday. Thank you guys so much.